Hello grade 11. Today we're going to be learning about the nature of roots. Okay, so what they mean about the nature of root, they mean that how will the graph be on the Cartesian plane. Okay, for an example, here we have our Cartesian plane, and then the graph of this parabola, it can either be like this. Can you see this? It's not touching the x-axis, or it can be like this. Here you can see that this point and this point touch the x-axis, or it can be like this. You see, the graph only touched this point. Okay, so when they talk about the nature of roots, they refer to that. Okay, so for an example, we have an equation here. Okay, let's first solve for x. Okay, we're going to factorize x and x, and then minus 4 plus 1. Okay, so x is going to be equals to 4, or x is going to be equals to minus 1. All right, then we take this, we put them on the Cartesian plane. Okay, and 4. If we were to draw a graph, we're going to draw it like this, right? Okay, we don't know the value of the, okay, we know the value of the y-intercept, but we're not focusing on that right now, guys. Okay, we're just focusing on this point. Okay, so if you solve for x for this equation, this will be called the roots of the equation. You see that? Okay, this will be called the roots of the equation. So with the nature of roots, you don't have to solve for x in order to know how the graph will be situated on the Cartesian plane. It doesn't have to be, it's not about the exact point, it's about how the graph will be positioned. Okay, whether the graph will touch at these 2 points, it can be this side, we don't know. Okay, or whether the graph won't touch the graph, or whether the graph is just going to touch 1 point and 10. Understand? Okay, so we have 3 ways to know how the graph will be on the Cartesian plane. Okay, and then that's called, we know that by solving the discriminant of our equation. This is come from the quadratic formula: x equals to minus b plus or minus square root of b squared minus 4ac over 2a. So what we need, we take what's inside the square root, and that's called the discriminant. Discriminant, we can also write it as a triangle. So what we do is that we find the values of a, the value of a, the value of b, the value of c, and we substitute it here. Okay, so the answer that we'll get here will tell us how the graph will be on the Cartesian plane. Okay, so there are 3 different ways, answers that we'll get. Okay, if you substitute the values here, you might find that the discriminant is equals to 0, or the discriminant is greater than 0, or the discriminant is less than 0. Okay, so if you find that the discriminant is greater, so the discriminant is equals to 0. So what this tells us is that the roots, okay, once you solve the x, when you find those values of x, the roots of x will be real, will be rational, and will be equal. So in the graph is going to touch 1 point on the Cartesian plane. We don't know where, but we just know that on the x-axis, the graph is just going to be like this. Touch on the x-axis just once, and then move up. Okay, and then if you find that if you find the discriminant is greater than 0, okay, there's 2. Okay, the roots will be real, rational, and unequal. Okay, unequal. Okay, or the roots can be real, irrational, and unequal, guys. okay, unequal. So how do we know that the roots will be real, rational, or unequal, or the roots will be real, irrational, and unequal? So if you find that your discriminant is equal to a perfect square, okay, a perfect square is a number that when you square it, let me just give an example of perfect square. 1 to the power 2, you're gonna get a what? 2 to the power 2, you're gonna get a 4. 3 to the power 2, you're gonna get a 9. These are perfect squares, guys. These are perfect squares. Perfect squares, if you find that your discriminant is a perfect square, then the roots will be real, rational, and equal. But if you find that your discriminant is just any number, but which is greater than 0, it can be 2. Find that discriminant is equals to 2, then the roots will be real, irrational, and unequal. Okay, so when you come to the graph, the graph will be like this. You see, the roots are unequal. Okay, but the difference between these two, even though both the discriminant is greater than 0, just that the real, rational, and unequal perfect squares, your discriminant is a perfect square, and then real, irrational, and equal, the discriminant is greater than 0, but you find that discriminant is like, let's say 12, 85, those numbers. Okay, then that's how you know whether the nature of the roots will be real, irrational, and unequal. Okay, what about the discriminant is less than 1? If right is less than 0, if right now they give you a quadratic equation and then say what is the nature of the roots, and you substitute your a, your b, and your c on this formula, and then you find that your discriminant is less than 0. Okay, whenever you find discriminant less than 0, it means that your answer of the discriminant is going to be a minus. It can be -1, -2. Okay, this tells us that we won't have any roots. The equation doesn't have any roots, so on the graph it's going to be like this. It can be here, it can go like there, or it can be down here, or it can be down here. Okay, if your discriminant is less than 0 and is a negative, so it means that if you were to solve the x using the quadratic formula, the discriminant here will be a negative, and a negative under a square root, you'll get error. So you won't be able to solve for x. You won't be able to find the roots of that equation, which is why we say that the roots are non-real. Okay, the roots are non-real. Okay, so let's use the first example, this one. Okay, we are going to find the nature of the roots. Okay, so our a is equals to 1, our b is equals to -3, and our c is equals to -4. Okay, so the discriminant is equals to b squared minus 4ac. Okay, what is b? Our b is -3 squared, 4a, which is 1, c, which is -4. Okay, let's put this on a calculator and see what we are going to find. Okay, so we're going to say open bracket -3 squared minus 4 -3 squared minus 4 times 1 times -4. So our answer, we got 25. Okay, let's go here. We said that the roots can be equal to 0, greater than 0, or less than 0. So what you found here, we found that the roots are greater than 0, right? Meaning that the roots can either be real, rational, or unequal, or real, irrational, or unequal. So what number do we have? We have a perfect square, which is 25. So it means that the roots will be real, rational, and equal. So the roots of this quadratic equation will be real, rational, and unequal.